Oh, hey, you guys still here? All right, I guess if you guys are still here, I'll keep going. Anyway, so my name's Chris Athanas. I'm a KMP Kotlin multi-platform developer, and today we're going to be going through the speech part of the code, which is I it was a little tricky figuring out the strategy to do which way to go with this, but I eventually figured it out, and I want to share with you my findings. Um, so I attempted two different ways that are in the code. I'm going to leave both of them in there because I think it's useful to see both ways and they're good for reference. Um, so one way is the way I tried first, which is what I'm going to share first, which I'm going to call technique number two. If you can't do technique number one, this is technique number two, which is basically setting up a bridge using this common flow, this library or technique or little tiny little function snippet really called common flow, which allows Swift to work like how flow does. So it can collect flows, emissions from flows, and can also emit into flows as well. So and I show how that's done for speech. And even though I abandoned this technique for the speech, it became useful for the billing. So there was no lost work on that one. So this one, yeah. So it says the commands from the Kotlin shared to the platform specific. In this case, I just did iOS. Of course, you could do the same thing with Android if you want to do it this way. But I only implemented the one for iOS because I eventually because I already had Android working, and I realized through this process that I didn't have to do all this. But it's a really great case because it's super simple. It's only three things. There's one to send a command, one to check to see if it's still speaking, and one to stop it. So very simple API that you can that I'm going to go through here in a second. And then the other way is just to call the native code for the platform from Kotlin, and that's what I've ended up doing. It's super simple, like it's way more straightforward. And instead of asking for the delegate to set, reactively set when the speech is stopping, I'm just polling every 250 milliseconds. Is speech coming? Is speech coming? And that's coming from the shared side. So it's just polling from the shared side. So it's not doing anything special on the. So I know it may be inefficient, but I think once every 250 milliseconds checking a flag, I think it's okay. And I kind of am a fan of polling. Some people aren't. You can go crazy with it. It definitely doesn't scale, but for a small app like this, why not? Yeah, it works great. So yeah, so current speak interpretation uses number one, which is call the native code for the platform from Kotlin. And yeah, polls. It does a polling here, and I don't use any flow for the speech at all in the final implementation, which I'll share. Yeah, so like I said, it was useful to explore these techniques for the in-app billing, which is the next video I'm about to do. And I left both of them in there, and we're gonna discuss it. Discuss what it is. So here it is in the app. It's the speech here is passed in. This is only for the iOS side. For billing, it's you notice I've got it both for billing here for the common billing, which it does Android and iOS in a very similar way as I'm about to show you for iOS. I'm gonna show the flow, how the flow style works. Um, so I pass it in here, right here, and let's see here. Okay, sorry about that. My phone just started talking for no reason. I don't understand what it's saying. Anyway, so yeah, this is where the IDE is starting to break down because these are grayed out, but they're definitely being called from the Swift side. So um yeah, so some of these integrations are still are lagging behind. and I guess we'll fix those out eventually, once KMP becomes more popular. So here in this common flow, which is coming from here, this common speech, then this common speech is created on the iOS side during the init. This is another thing that doesn't is making cross-platform development a little more difficult. There's no that text styling, syntax highlighting, nothing. So I can't use my tools to collapse them open the normal IDE tools, which is kind of lame. So I'm hoping they'll fix that eventually. Maybe we can have a little highlighting, even though I'm not going to show the debugging or build errors. It would be nice to have just highlighting. Anyway, so here we're setting up the text-to-speech manager here with this is implementation number 2. So we're opening the set to speech and we're actually passing in this common speech right here. So the common speech structure is initiated on the iOS side, is initialized on the iOS side, instantiated, and then passed into this text-to-speech manager, which includes this common speech, which is this thing. And that contains the flow where you can speak the commands and update the speech state and speak the text here coming from the iOS side and the shared side. And it's actually instantiating one of these text-to-speech managers, which is it passes in one of these this common speech here, and that's how it actually interacts with the iOS code. This is the actual where the iOS code does all of its thing, and this is when the does all the speech calls to the iOS side, which actually runs it runs, and this is all in the Swift. So this is one technique where you can have these samples that you find. Like for me, it's like I'm not an iOS developer. I don't know Swift. I'm still learning quite a bit. I'm still like beginner intermediate on iOS right now. So finding examples of how this works, that's one of the things that iOS developers definitely are spoiled with. There's lots of examples and they're all pretty straightforward and simple work. So using this bridge is a way to just like, okay, I'm going to use this example, but I'm going to talk to it from my Kotlin native side using Flow. So this is one of the techniques that I've discovered or I'm using, or I don't know if discovered or whatever, but this is how this seems to work pretty good. It's actually very, very scalable. I'm gonna go over here to Xcode. Yeah, so I want to demo that this actually works, but there's some strange things going on with how the speech synthesis on iOS detects what the language is. So I don't know what I'm gonna do about with this, but so yeah, so here, let me get the hooked up here. Oh.
Marker details for the ANSA Expedition 1.
Nearby marker de ANSA Expedition 1775-1776.
See, that one thought it was German, but it's Dianza. It's like obviously Spanish. So there's like some of these things on just detectors.
Marker details for Unlock House.
But this one, it gets the Russian.
Marker details for Ocean Hill, og subtitle of California,
Yeah,
San
so this one's got all
Francisco
kinds
City
of.
and County, San
This one's got all kinds of
Francisco,
Russian
Hill
in
has
it. But you can see the flow stuff works pretty good. So, and now let me go set it up for just the way that I'm gonna go with the implementation, which is way simpler than all this flow stuff. So I turned off implementation number 1, and I was using implementation number 2. So you can turn them off easily just by commenting out this one and then uncommenting all this. And then recompiling, which I'll be back in a minute. All right, so yeah, so basically what I decided to do is to use this just the native stuff. So here is the native implementation of that text to speech manager, which is almost the same, almost exactly the same thing as this. Doing this is what made me realize, oh, I can just do one or the other. It doesn't matter. I mean, it does kind of matter because there seems to be some little bit of issues still trying to use the Kotlin implementation of some of these libraries, especially with Google Maps. I ran into. I'll talk about it in one of the videos after the billing. There are issues. So when you run into those issues, it's nice to have a backup that's just like, okay, we don't have to use Kotlin. I mean, if for this all native platform stuff, I think it's totally okay for this, this stuff that can be segregated away. So basically, right here, it's like here's the code on iOS on the iOS side, which kind of mirrors the way it works on Android. You have this text speech manager, and you basically do the stop speaking, and speaking. And then this is the manager right here, which then does the calls directly and also overrides delegate. And this is the Kotlin side of things. So it looks very similar to the iOS side, but there's enough differences that make it like, I should just. Sometimes it's a trade-off. If you have a bunch of sample code, which basically this was, maybe it's best just to use the common flow and communicate back and forth that way, a little bit ping pong. But if you can get away with running it native, I mean, it's all that ping pong code, common blah 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 blah, is all just right here now. So there's none of that other stuff. So yeah, that's kind of how the tech stuff works. And let's see, what else do I gotta say here? Anything else I want to talk about? Nope. I think that's about it for now. Next one is going to be in-app billing. How that's all put together. It's using this flow ping pong technique. Yeah, and thanks for sticking with me.